Hello and welcome to today's webinar. My name is Tyler Reid. I'm the Manufacturing Applications Manager here at GoEngineer. And today I get to introduce everybody to the newest machine from Stratasys, the J750. I'm super excited to be giving this webinar because I am really excited about this new machine. When it was announced last week, I was so surprised. I had heard that some beta programs were going on with this machine for a few months back, but I didn't really understand just how incredible this new machine is until the full announcement came on. This webinar is being broadcast live, which means I'll be able to take your questions as you have them. When you do have a question, go ahead and type it into the GoToMeeting chat window or the questions box. We'll look at those at the end and periodically throughout the webinar. So the new Stratasys J750, it's actually the third generation multi-material machine from Stratasys. So Stratasys, back in 2004, produced a machine called the Eden. And the Eden was a multi-jetting technology using resin. It was able to produce the fine details, the ultra-thin walls, and the highly accurate parts that we're used to today on the Connex machines. The first Connex came out in 2007, and this was revolutionary at the time. It was the first multi-material 3D printer. So with this printer, you could actually print two materials side by side. You couldn't really do that before. In 2014, so just a couple years ago, the Connex 3 came out. And I was around, I was in the industry when the Connex 3 came out. And at the time, I thought it was the greatest thing ever. The addition of just one extra material beyond the Connex's two materials was a lifesaver. For prototyping, it meant that you could do a wider variety of materials. You could do more versatile prototypes. It also allowed us to create digital materials that are produced from the mixing of two materials prior to curing. So things like digital ABS were made available. And then on top of that, you could do a digital material as well as an additional material. So you could do digital ABS with overmolding, for example. Also with the Connex 3, they introduced color for the first time on a multi-material printer. So we could load up to 3 materials. Those could be a combination of colors, some of the muted rigid or transparent materials, or rubbers. And we got along pretty well. But now with the new J750, Stratasys has doubled the amount of materials that we can load up at one time. So we can now load 6 materials that can be a range of all colors or some of the muted rigid materials, do flexible materials, we can do transparent materials. This gives us a huge range of possibilities when you think about the ability to actually mix all of these materials at one time. So I like to say the best is getting better. The best was the Connex 3, and now with the J750, we've got even more possibilities. When it comes to color, we have over 360,000 color options now. Alongside the color, we have all the tried and true materials as well. We have the digital materials, we have the rubber-like materials, and we have transparent. But now we can print a wider variety of those within the same part or within the same tray. Okay, so we can do full color parts alongside digital ABS, alongside rubber, for example, without reloading the materials. That's huge. We're also getting new software for the J750. It's going to be called POLYJET Studio, and we'll be talking more about it near the end of this webinar. We're also getting new upgraded hardware in the J750. So this is the most advanced hardware to come out of Stratasys. We'll be talking more about the print heads in detail. All of these 3 things together is the new Stratasys J750. So let's take a look at some pictures. We're going to get full spectrum printing. Like I mentioned, it's about 360,000 colors. I think the real number is about 362,000 colors. The way we specify and place and control these colors is going to happen in one of 2 ways. You're going to place the colors inside your CAD model and output a VRML file, or you're going to use the new Adobe Creative Colors software from Stratasys, which is a plugin inside the Adobe software, to create color maps and textures and place those on your part inside the new POLYJET Studio software. Okay, so if you've been using the Connex 3 and you're familiar with how colors work in the Connex 3, this is going to be very different. For the most part. Because we have the option to use that Adobe Creative Colors suite, that's going to allow us to create some very complex textures, patterns, things like wood grain, carbon fiber, decals, anything you could think of. This is the way that we should have been doing color a long time. It's just the technology wasn't there. Don't forget, you're still going to have your engineering grade plastics with the J750. So digital ABS is a perfect example of a plastic that kind of goes beyond prototyping. Short run injection mold inserts is a hot topic, and digital ABS is really the go-to material for that. Other tooling options include thermoforming patterns, carbon fiber layup patterns, highly precise jigs and fixtures, parts that you're going to see on the shop floor. You're still going to have those options on the J750. You're not giving up any functionality. You're still going to be able to do both single material and overmolded parts. Okay, you're just going to have more color options when it comes to those single material parts, and you're not going to lose the overmolding capability. Not only are you going to be able to do single material and multi-material, but also single color and full color as well. Okay, so you're going to be able to pick your colors the same way you would have done in the Object Studio software. It's just going to be a little bit more streamlined. It was a big goal of Stratasys to streamline that 3D printing workflow that, even with a regular Connex, would include the CAD modeler, it would include Object Studio, it would include some admittedly not very smooth methods of choosing colors, especially if you have a lot of different colors. And then on more traditional or some of our competitors' machines that produce less realistic parts, there's going to be a lot more post-processing as well. The post-processing for the J750 is going to be the exact same as the Connex 3. It's that sort of waxy support material that's water jetted off, and that produces a part. If we go back couple slides here, it produces a part with good enough surface quality that you can use it for an injection molded part. Very hands-off process that's quick. The time from printing to the part in your hand is much quicker. You're eliminating sanding, painting, other post-processing. You're still going to have flexible and rigid materials, okay, side by side in the same part or in the same tray. Looking at this shoe, this is one of the sample parts that Stratasys has been showing photos of, and I can't look away from it. I can't believe that's 3D printed. It looks so good. It looks so realistic. If you can see the purple fading into the maroon, it's just so flawless, right? And the fact that it's a functional prototype, you could actually put that on your foot or put it in a test fixture. Because you have simulated durometers, you're going to be able to get some really good information out of that prototype. You could put this in the hands of a prospective customer, and they're going to know instantly what they're getting. What is the final product going to look like? It's going to look exactly like this. That amount of good information that they get from a prototype is going to help you make sales. We're still going to have our matte and gloss finish options as well. So we've always had the ability to choose the finish on our parts. If we choose gloss, it's going to produce a part that is using a minimal amount of support material. So wherever there is no support material, it ends up with a gloss finish. If we choose the matte, it actually coats the whole part in support material, and that interface between support and model leaves you with a nice sort of matte finish. We're still going to have those options here. Again, look at this print. I can't believe this has been printed. This looks like it's been hydro dipped or water printed, right? This sort of texture and that sort of color, I honestly never even dreamed that we could get something that good looking out of a 3D printed part. You're still going to be able to do fine and large features. And actually, we're going to be able to do finer features on the J750 than we could on the Connex machines. The reason is the improved printhead technology is going to give us finer Z layer resolution. These might be some of the coolest models that I've seen. Again, we're still going to have the ability to do opaque parts, fully transparent parts, and clear tinted parts as well. We're just going to be able to do more of those within the same build or within the same tray. So you're going to be able to produce parts like this that have all of the color information that you could possibly want can be transferred to the printed part. So the question was, that telescope looks very round. What's the layer thickness / resolution? So in prior machines, the finest Z resolution was 16 microns. Okay, so that's about 6/10,000ths of an inch. These new printheads on the J750 will go down to 14 microns. That particular part, the telescope, since I didn't print it, I don't know what layer resolution it was actually printed at, because there are several options. You can choose high quality or high speed. So that gives you a little bit of flexibility in the time to print. I briefly mentioned this when it comes to dictating the colors. You're going to be able to do shell colors or texture VRMLs either out of SOLIDWORKS or your CAD tool of choice, or the Adobe Creative Colors software. So the result of all of those is basically just unprecedented realism when it comes to 3D printed components. When you look at that on your computer screen, you might at first glance think that that is a real plate of sushi, and it's not. It's 3D printed. But the closer you look, you'll start to see some of the layering lines. That's the only evidence of it being 3D printed. It's the only evidence. The color doesn't give it away. The textures don't give it away. So who can use the J750? Well, everybody can use it because it's so easy, but who is going to get the most benefit out of a machine like the J750? When it comes to designers want concept prototypes that are the most realistic as possible so that they can communicate their designs to people who are going to give them feedback. And the better that communication is, the better the feedback and the better the improvements. So designers are going to love it. Marketing people, they also want realism. They want something as realistic as possible. In fact, if they can have something so realistic that they can use a photo of a 3D printed part in their marketing materials, that means that they're going to be able to produce those marketing materials much sooner in the process than if they have to wait for a first article part to go through manufacturing. They want prototypes that help the customers understand the final product. And the more realistic that final product is, the better the customers are going to understand. Engineers also want realistic prototypes, say for manufacturing instructions. They also want 3D printed FEA parts, like we saw in the couple slides ago, to help them communicate their results to their coworkers and to their management. The guy that ties that all together, the person who's actually running the machine, the RP manager, what he needs, again, high product realism, he needs minimal cost per part, and that means lower costs on material and lower cost on labor. That's where companies that run service bureaus or print-on-demand services are going to love the J750, because when they can load up 6 different materials at a time, that means they can print a wider variety of parts without having to load and unload those material cartridges. Every time you load and unload a material cartridge, it's going to cost you time. It's also going to cost you a few dollars in the amount of material that you have to purge. So that means they're going to be able to take on a wider variety of jobs, print them at the same time, deliver them faster. So for example, in consumer goods, if you're looking at packaging, you might want to prototype the packaging, and you don't have to want to go to an actual 2D printer, print on some sort of compression plastic. You just want to take the digital file and print it directly. We can do that now. When it comes to consumer goods like those shoes, both the concept and presentation prototypes, they're going to be realistic in terms of the colors, the textures, the softness or hardness of the materials. Toys are another one. Toys are very visual. If you're going to be producing a toy, the colors are actually going to be a big part of what makes the final product the final product. And when it comes to automotive, stuff like wood grain dashboards, carbon fiber dashes, those are going to make better prototypes as well. So all of that sort of accumulates into the idea that we can more freely create without overhead or less overhead. We're going to eliminate the need to invest in several different technologies to achieve a final part. The J750 is really the best of many different technologies. It offers the most amount of materials than any other technology. It's going to offer the widest variety within those materials than any other technology. And it's also going to let you print more of those materials side by side than any other technology. Before the J750, you would need multiple machines to do the same thing. That means you need more space, you need more machinery investment, and you need to stock more materials. We don't want to do that. Because of the layer resolution and the fine printing on the 750, we're going to eliminate a lot of the post-production needed. We're going to eliminate a lot of painting. With the ability of doing the colors and the textures and the grains and the decals and the fades and the gradients, we're not going to have to paint. We're going to eliminate a lot of sanding because we have that finer layer resolution. Overmolding. We don't have to do overmolding as a post-process. We can overmold or do rubber-like material over a rigid material right on the machine. So really, we're reducing the design limitations here. Here's a case study from Stratasys. It comes from a company called Synergy. They were part of the beta program. Synergy, for their prototypes, were implementing several different processes that they had to outsource. They were getting CNC machined prototypes. In order to get the color textures, it would go to water printing or hydro dipping. In order to produce some of the buttons, they would be cast and then sanded and then silicone engraved and pad printed. So you're seeing some examples of their prototypes there. These go up near your rear view mirror in your car, and they have silicone buttons, okay? With a single printer, they were able to eliminate all of those steps that they had to outsource. They were able to print directly their prototypes that have the rigid casing, they have the rubber-like buttons. The buttons have all the details already printed into them. They have accurate colors. So the time for prototypes was cut from 2 weeks to just a couple hours. And the cost of the prototype was actually cut by over 70%. Okay, you can't beat that. You can't beat it. So what does it mean to go to a full color spectrum where you have cyan, magenta, yellow, black, and white? It means you're not compromising on the color. You get to more realistically represent the final part. And you're also going to be able to precisely define the color. So I included some images here. You have some examples of the same part printed on the J750 versus the CONX3. The CONX3 has been great up till now, and it still is, but we just don't have quite the same versatility in the colors. So you can see how realistic the color is on the J750 part. That's the intended color. The CONX3, we just can't quite get there. With the cyan, magenta, and yellow, we can get a couple different combinations, but we just can't quite get there. Real quick, there's a question. Instead of layering, is it possible to print varying thickness? It's not currently possible to vary the thickness within the part. Okay, that would be a great enhancement, and I hope it comes, but we don't have that right now. It would make sense in areas where all the walls are vertical, maybe print more coarse, and where a lot of the walls are more shallow, like maybe cresting over the top of this bottle, for example, to go to a finer resolution. That would make sense, but right now the technology isn't capable of that. Like I mentioned, in the automotive application, we're going to be able to more accurately produce wood grain and carbon textures. So if you look at the part on the left, that's been printed on the 750, and the part on the right, the CONX3. The CONX3 just doesn't quite have the same pop. It doesn't have the same realism. And when it comes to that little knob on the top, there's no carbon fiber texture because they couldn't do any sort of white. Very hard to get realistic parts when you don't have white, or a true black for that matter. When it comes to simulating textiles and all the textures that they have with them, and also colors, that's where having 6 colors over 3 is going to make a huge difference. I wish I knew the name of this little mascot, but he appears in a lot of the Stratasys promotional videos, and he's never been quite lifelike. But now with the J750, hopefully that changes a little bit. The CONX3 part, he just looks dead in the eyes. He almost looks zombie-like. If I was putting that in the hands of a prospective customer, that's probably not the message that I would want to convey. You're going to be able to do color and rubber on the same part. What's new about that is you're going to be able to do rigid colors and rubbers on the same part. On the CONX3, if you wanted color, it would either have to be, pure cyan, yellow, or magenta, or a slightly colored rubber-like material. Here's the big thing that I mentioned before. You're going to be able to keep 6 materials loaded at all times. So you're going to eliminate a lot of the replacement costs of keeping all these materials loading and unloading them. If you're a service bureau and you have a job that's going to require color and you have a job that's going to require rubber-like material and it's maybe some overmolding, before you'd have to print those one at a time. And if it's a 4 or 8 hour build, that's going to delay you a half day or a full day. But now with the 750, you can actually print those at the same time, and you're going to save a day on that second job. So the new software, the POLYJET Studio software, it's going to allow you to import VRML files. So if you haven't used a VRML file, it's similar to an STL file, but it has color data. And those VRML files, they can be solid colors or they can be textures and full color mapping. It's going to allow you to save custom color palettes, obviously mix both color and rubber. And again, it's going to allow you to mix the digital materials with the transparent and the rubber and the color on a single part or a single tray. You're going to retain your matte or glossy finish. You can choose color profiles and intents. So you can actually save color profiles for maybe different families of parts, different marketing materials. If I'm going to be printing a lot of parts that are GoEngineer branded, I can save those colors and really rapidly produce parts in those colors. And if I'm printing multiple parts, I can also copy colors between parts as well. With the new hardware and the new capabilities, it was imperative that they came out with the new software, and I'm glad Stratasys recognized that, and it's actually much smoother to use than the Object Studio software. So behind the scenes, let's talk a little bit about the nozzles. They have a new nozzle design, new print heads with those nozzles. We have 2 material channels per print head, and each of those print heads has 4 times the number of nozzles. Okay, so we're actually going to get parts with tighter resolution on the J750, but also we're going to get higher print speeds, particularly when it comes to the digital materials. So for example, a digital ABS tool. If you had a part that you printed on the Connex 3 and it took 6 hours, on the J750, it's going to take about 3. It's about 2 times faster on digital materials. So the same thing applies for digital ABS and also a lot of the simulated rubbers as well. If you do, say, Shore 65 rubber, that requires a digital material, and that's going to print about 2 times as fast. I'll also mention this, I don't have any of this information in the slide set, but all of the J750s are shipping with a 3-year diamond status warranty. So that's the highest status warranty that Stratasys offers, and it's automatic 3 years. And that covers print heads, it covers everything. I'll leave it on this page for a second here. We're going to see some of the J750 specs. So we're down to 1800 DPI on the Z-axis. You can see the maximum build size is that approximately 19 inches by 15 inches by 8 inches. It is the same build size as the Connex 3 500, I should say. So the Connex 3 is available in 3 different sizes, the 260, the 350, and the 500. The J750 is only available in one size, and it's that high-end size. And that is all I have for you guys. This is a pretty good time. If you have any other questions, type them into the questions box now or the chat window. If you want a copy of these slides or if you'd like links to any of the J750 data, you can shoot me an email, treid@GoEngineer. If you're curious about more applications of our printers, we talked about injection molding, we talked about thermoforming. If those sort of entice you, check out our YouTube page, youtube.com/GoEngineer. We have several webinars that are 30 to 45 minutes long that are going into all of those applications in depth. So I want to thank you guys for joining us. Thank you.